for notes, so we are done with announcements. Maybe, there we go. We're done with announcements. We're going to jump into our notes. So as a reminder, because it's the first day back from break, I know my brain is a little crazy too. And we haven't really done notes because we were working on PT and stuff. So for your notes, you have two options. One is live action. You can stick around here and you can hang out with me, and we'll go through all of it live time, be able to ask those good questions, okay? If you would prefer to go slower or faster, we do have the option for a team video. It's linked on Canvas. It's also linked on your assignment. It's also linked on the notes page. So you can find it in many different places. It's also, if you subscribe to my, like, comment, subscribe to my YouTube channel, you can also find it there. But that's probably the hardest way to find it, to be honest. So we're gonna jump into the notes. What I'm gonna do to help you out with that, because I noticed at least a couple of people were like, I can't really watch the notes and stay on the call. So I'm gonna go ahead and open up your breakout rooms. So Zoom added a really cool update, guys. You can now choose what rooms to go to. So it's gonna like auto assign you to your like your learning squad or to the ACC room, but you can now choose to be in a room or not be in a room, which is pretty cool. So if you would like to, there are a bunch of different options here. You can go to your like learning squad room and watch the video with your team. You can jump into an independent workspace and just like work silently in that room. Or I will also have an option if you would like to jump into a support group, you can talk to the TAs. So pretty pumped about all of these things. So I'm going to open up these rooms. If you want to go to them, you can. If you don't want to, you can stay here and do the notes with me. And I'm going to switch over my screen share while you make that decision. So you're either staying here or you're going to a breakout room if you wish. And you can now like choose to put yourself in that moment. All right. Set that chair and pick up this one. iPad. Wait for it. Here we go. All right. You should be able to see the notes. Yes. If you're on my screen, if you've got your video on, can you give me a thumbs up if you can see my notes? Cool. Thank you. Thank you. Okay. So you have access to the notes page if you want it. And then you also have, you can also just like write it on paper. I want to own that like quadratics are kind of annoying. So do your best to take notes if you're taking it on paper. Just want you to pretend that you're in a college class and your professor doesn't print stuff out for you. You're going to do your best to take notes. Sound like a plan? Cool, cool. All right, let's jump in. All right, so we're going to start talking about quadratics this quarter. Quadratics are just parabolas, right? Parabolas. And they can be open up like this or open down like this, right? So they can be, I call it like up like a cup or down like a frown, right? So up like a cup, down like a frown. And we're going to talk about some of their like key features. Okay, so key features, so things that like make them important. Okay, so I have two boxes here. You can include them or not include them in your own notes, but I think that it's nice to think about things in like colloquial terms or mathematical terms. Does anyone know what the word colloquial means? You can chat it if you want. Colloquial. Okay. So colloquial means that you, these are like the things that you would say in normal life, right? So not necessarily like mathy words, but these are what like normal words, like words you would use in your culture. So the word like lit is a colloquial term, right? It means like something like it means good, like it was cool. A mathematical word would be like the word vertex. That's a word that we probably don't usually use in our regular life, but we use it a lot in math. So colloquially, we would say something like this opens up or opens down. So up like a cup, down like a frown. Those are not really mathematical things. Those are just things Ms. Mac said, right? The mathematical way that we would say this is concave up, right? Which is like the graph that we see, or concave down, right? So opens up, looks like this, opens down, looks like that. So in this situation, we have something that is concave up, right? Because it's opening up. Like if I was to pour water into it, it would hold the water in my cup. Right? And then we have a couple points that are really important, right? A couple points that are important, which are these 4 points. I'm gonna give you a second to write them down. Make sure that you have like a graph. We'll jump in. So I'm gonna start first by talking about the orange points, right? The orange points. So the orange points have a few different names, but the first one I'm going to use, the one we're going to use most often is solutions. These are our x-intercepts, right? X-intercepts. So our solutions are x-intercepts. So colloquially, we might call them like where it crosses the x-axis. And the mathematical term would be the solution or the x-intercept. In some situations, you hear them called you hear them called like the roots. And then there's another zeros. There are like 4 different words. We talked about the same one, right? 4 different words. I heard someone come off mute. Did they help me out? Or just accident maybe? Cool. Okay. So where it crosses the x-axis, those are our solutions. Does anyone know the name of the blue dot here? Like what would we consider this point right here, the blue dot? So if our x-axis, yeah, our y-axis, right, is the line. So then that point right there is the y-intercept, for sure. The y-intercept. So where it crosses the y-axis, so where it crosses y is called the y-intercept. It doesn't really have any other fancy names. It's just the y-intercept. Yeah. All right. And then does anyone know we have this other point, this green point right here, right? The green point, I'd say it's like colloquially, or like we would just normally call it the turning point, like where it's going down and then it starts to go back up. Does anyone know what the math word is for that? Middle is like another colloquial word for it. The middle, it starts with a V. It's the word vertex. Anyone heard that word before? Yeah, vertex. Good job, Ellie. Good job, Gabby. The vertex, right? So that middle point right there, and it could be on top or it could be on bottom. Right? In this situation, it's the lowest point. That's the vertex. Which brings us to something important, which is the difference between the lowest point and the highest point. So the lowest point is what we call the minimum point, okay? The lowest point is what we call the minimum point. And then the highest point is what we call the maximum, right? So the lowest point, if the graph is concave up like this, that would be the minimum. And then if it was concave down like this, that would be the maximum. So we have the min and the max. Right, so this green point here would be a vertex. And then in this situation, would it be a minimum or would it be a maximum? Go ahead and speed chat that. A minimum, yeah, it'd be a minimum. It's the lowest point. In this case, it's a minimum for sure. All right. And then just so you guys are aware, we're going to jump into something here in a second, but there is something called the axis of symmetry, which is basically just a line that cuts the graph in half, right? So it's a line that cuts the graph in half. So I'm going to use this part of my paper here really fast. Basically, if I have a graph that looks like this, right? Then I have an axis of symmetry that cuts down the center like this. This would be my axis of symmetry. And we always write the axis of symmetry as an equation, okay? An equation. And since it's straight up and down, it is an x, right? So this would be x equals, and whatever this number is. So maybe it's like 1, 2, 3, 4, 5, 6, right? Maybe this is 6, so this would be x equals 6. Okay, so that's my axis of symmetry. Yeah, Nebu, I can go back in just a second when they give us like a break-ish. All right, so that's my axis of symmetry. Are there any questions about the different words that we have talked about today? Concave up, concave down, solutions, roots, y-intercepts, vertexes, mins, max. Okay. I want to give us a second to practice with this vocabulary. So I'm actually going to have us do part of our assignment. I'm going to give us 5 minutes. What I want you to do for the next 5 minutes is I want you to go to this IXL that I just posted in the chat. Go to this IXL and log in really fast. Make sure that you log in. And then I want you to just practice with the IXL. Okay. I'll do some like practice as well, but for the next 5 minutes, I just want us to take 5 minutes. So we'll come back at 1:49. 1:49. I want us to practice the IXL until 1:49. I think you might even be able to get part 1 done during this time if you're feeling pretty good about this language. So practice IXL until 1:49. So you're jumping on that link. All right. If you missed the directions, we're using that IXL link. We're practicing these questions. Good job. See some people already at like 35. Good job. Some people already at 60. Good job. Feel free to use the private chat if you're interested in asking some questions. So the equation of the axis of symmetry, great question, is going to be the center line of the parabola. So let me jump to that question on my screen as well. Give me 1 second. I'm going to do one of those since we didn't talk about it too much. So for example, you should be able to see my screen. This one asks for the coordinates of the vertex, but let's say it asks for the axis of symmetry. If it asks for the axis of symmetry, I'm going to go to the center point, the vertex, right? Oops, sorry, give it a second to catch up. I'm going to go to the center point, and I see the vertex is here, right? The vertex is here. So the line that cuts it in half would go right here, right? And I can see that the x value is 3 because I'm going over 1, 2, 3. So the equation of the axis of symmetry in this case would be x equals 3. X equals 3. So for the axis of symmetry, you should always do x equals 3, or like x equals the number. You're welcome. See that you should go to your number. So either 60 if you're star, star, star. You should go to 75 if you are on track. You should go to 90 if you are honors or ACC. 90 if you're honors or ACC. Yeah. All right. All right, all right. So for example, give my computer here a second to catch up. Yeah, let's do an axis of symmetry one. My internet is tripping out. So for example, for axis of symmetry, here is a graph, right? If I was gonna go, I'm gonna go to the center of it, the vertex would be right here. And the axis of symmetry is the line that cuts it in half, right? So the line that cuts it in half. And right here, I'm at the 0, on the x-axis, I'm at 0. So this would be x equals 0. The correct answer is x equals 0. As I was doing this, most of them were x equals 0. So you can try that one as well. Let's say I was looking at this graph, for example, right? If I was looking for the axis of symmetry, go to the center point, cut it in half. Okay, I'm gonna go up here. This is x equals 2. And you do have to put the x equals because it is an equation axis. Equation of the axis of symmetry. Okay. Cool. Okay. I gave you a few extra minutes. I'm going to have us pause on IXL for just a moment. right? So if you are on IXL, go ahead and pause. I do want to explain the second section of our notes today. When it says the maximum value, I'm going to answer this question before we move on. The maximum value, that would be this point. It's like, what's the highest point? What's the highest point? So if I had a graph that looked like this, I would say, okay, the highest point is right here. So then whatever number this is, that would be at like 10. That would be my maximum value, my highest point. Okay. All right, I'm going to pause this on IXL for a moment. Try to drag yourself away from IXL. I do want us to think about for just a second what it means to solve by graphing. Solve by graphing. So to solve by graphing, what that means is to find the y-intercept. I'm sorry, find the x-intercept. Find the x-intercept. That is our goal. So there are a few different situations here, right? The first situation is that we have a graph that looks like this, right? And I can see that there is a solution here and a solution here, right? That would be two solutions. In this situation, we would have two solutions. You could also have a graph that goes like this. That also would have two solutions, right? Because I see both of the solutions there. Okay. We could also have a situation where we have like a line that comes in like this and then bounces back up and just touches one time, right? This would be considered one solution. And you could also have that same thing like this, like that one solution, okay? So that would be considered one solution. And then finally, you have the situation where you have no solutions. And no solutions means that it never touches the x-axis. So it might look like this, right? It doesn't touch here. Or it might look like this, right? It doesn't touch here. One thing that always, always, always trips people up, right, is they see something like this and they say that it has no solutions. But remember that a parabola continues on forever and ever and ever. So this actually would have two solutions, right? So we want to make sure that it's never going to touch. So this one actually would be two solutions. We don't want to put it here. Okay, so be careful. You want to make sure that it's never going to touch. Okay, so we have two solutions, one solution, or no solutions. Those are the options. Are there any questions about this section of the notes? Still working here. Cool. Okay. So sometimes they give us an equation like this one right here. Right? Sometimes they give us an equation. And in order to solve that equation, we have to do sort of three things. We want to make one side equal to 0. That's our first step. We're going to graph it, like type it in on Desmos. And then we're going to click on the solutions to see what it says. So for this one, I would say, okay, I have 2x squared plus 3x equals 4. I want to make one side equal to 0. So everything on the left side is already there. I'm going to go ahead and move the 4 by subtracting 4 on both sides. There's no like terms there, so I'm going to do 2x squared plus 3x minus 4 equals, and then 4 minus 4 is 0, like that. So that's my first step, is getting everything on one side of the equation. Everything on one side. And then once everything is on one side of the equation, I'm going to go ahead and type the equation into Desmos. So I'm going to go ahead and bring up Desmos here. I linked it on your assignment as well. and I typed it in like this. I don't need to put the equal 0. Notice when I put the equal 0, it does something else. I don't want that. So I'm not going to put in the equal 0. I'm just going to put in the 2x squared plus 3x minus 4. And then I can see my graph here, right? So I can see, okay, I have this point and this point. Those are my y-intercept or my x-intercepts. Here's my y-intercept. Here's my vertex, right? I care, and for solving, I only care about the x-intercept. Those are my solutions. The y-intercept doesn't matter and the vertex doesn't matter. So my two solutions are negative 2.35 and 0.85. So when I write my answers here, I'm going to write that my answer x equals 2.85. Is that it? I don't remember. I think so. 85. No, 35. Don't remember. I'm going to go back. Negative 2.351. So negative 2.351 and 0.851. Like that. So these would be my two solutions that I can have. Two solutions. And I know those are my two solutions because that is where it crosses the x-axis. So the solving portion is pretty simple. You just type it into decimals and then click on the pieces that you want. All right. That is our notes for today. I know we paused and did some of our work in the middle. So you're actually probably like partially done with your IXL. And then you're going to do some like decimals and screenshotting work, right? If you're having a hard time screenshotting, just let me know. You can still just type in your answers. That's fine. Okay. Okay. I am going to go ahead and we're done with our notes for today. I'm going to go ahead and release you to work on it on assignment 11. If you're feeling good about the IXL, you can head out. Otherwise, I'm going to do some of the IXL questions on my screen in case you are interested in seeing some IXL. So you can head out if you would like to, or you can stick around and do some IXL with me. Bye, everyone. Bye, guys. Bye. Bye, guys. Bye. See you soon.
Bye, Miss Mac. Have a great day.
Bye. Have a great day. Bye, guys. Bye. All right. Bye. If you are working on the IXL today, we might have, let me go ahead and go to this. Let's see, K.2. I think it's K.1, huh? Let's see. This one here. Bye, Roxana. Enjoy your day. All right. So if you're working on the IXL, it says, look at this graph. What is the y-intercept? So I'm looking at the y-axis here. And then I'm going to where it crosses the y-axis, which is right here, and it's at 0. So for this one, I'm going to click here, and I'm going to type in a 0, and then I'm going to press submit. That would be my y-axis. For this one, it says, what are the coordinates of the vertex? Remember, the vertex is where it, like the minimum point or the maximum point, the turning point. So that would be right here, this point right here. And the coordinate, so it would be x comma y. So it would be 0 comma 0 in this case, because it's that point there. So I'm going to click here, and I would have 0 comma 0. Submit. Got it. All right. For this one, the coordinates of the vertex is here. I'm not going left or right any, so it'd be 0 and then down 8. So I would put here, I would put 0 and negative 8, like that. Submit it, just like that. Okay. This one says y-intercept. So on the y-axis, right, on the y-axis, I would go right here. And I see it didn't quite make it to -5, it's -4. So I go here and put -4. So that, and then finally, this one says, what is the equation of the axis of symmetry? Right, remember the axis of symmetry is the line that goes here. It's an equation. It always starts with x equals, and in this situation, I see that it's x equals +1. So I'm going to type in a 1, x equals 1, like that. Okay. For this one, it's Gabby, 1 second. For this one, it says what's the minimum value, right? The minimum value. So the lowest point is right here, and the lowest point is at -1. I know it looks like 0, but remember 0 is up here, right? 0 is in the center. So the minimum, the lowest that it goes down to is -1. So I'm going to click here and do -1, like that. Press submit. Just like that. Okay. Go ahead and ask any questions that you have. And there's a few of us still here. Gabby, I'm going to go ahead and get your username here. Gabby Gab, your username is G Ramirez Alvarez at Ednovate. Is that what you have in there? Okay, and then I'm gonna give you your password. Are you typing that in as your password? Yep, there you go. You got it. All right, guys.